Alright, in this video, we will be creating a weighted selection for our selected tile. That way we can add in tile weights to make some tiles have a higher chance of being chosen. That is what a weighted selection is. So to do this, within our collapsed cell, we're going to want to create a function and call it weighted selection. It will need an input of our tiles with a set, the container type set to set, and an output of just a variable tile. Now, the other thing we're going to need is a new variable, a new map set to key of the tiles and the value to be integers. This is going to be our actual tile weights, and it is named as such, tile weights. Within here, you can add in all of your tiles. Maps are a little bit irritating. You can't reorganize them so it looks nice. However, the organization doesn't matter, as maps access things with keys. It doesn't care about where it is within this part of the map. But we're going to set the default values in here so we can just manipulate it here without having to add in some other initializing function to add all of these. So we'll see here that I have all of my different tile types. They're just arbitrarily right now at 100, except for filled, it is set to 500. And you can set these according to which you might want to spawn more often. And I originally made this as an attempt to control the generation a little bit more, and it works all right. However, it could probably be done more dynamically by affecting these tile weights in real time. So as things get collapsed, you can increase tile weights and decrease them. However, I have not personally explored that. All right, to actually implement this, we're going to go into the weighted selection. We need to immediately make the tile set into an array and set that as a local variable. We'll just call that tile options array. Then we want to make sure that it is not empty, as if it's empty, that will break our weighted selection and then break the actual choosing of a cell, and then continue to break everything down the line. And then we want to check to make sure that it's not equal to 1. We will explore what we will do if that's false. So as long as it is any number but 1, we're going to do a for each loop off of the tile options array. I don't know why I've done this. It's a local variable. And then we're going to add up all of these weights. So for each of the tile options that are within this given cell index, as each will be different, sometimes there will be maybe like filled, top, middle, left, and we need to get those 3 weights. We don't want to add everything. So that's what this will do. It'll take the options at this specific cell, and then it will find the corresponding key, whatever the key may be. It'll get that, and then the value will be that weight, and we will add it to a local variable called total weight, and we need to make sure that we add it to total weight and then set total weight. From there, what we need to do is just select a random weight from the total weight minus 1 and the minimum being 1. So from 1 to the total weight minus 1, we will pick a random integer and set that to a random weight. And then I still have these. I don't know why I did that. This is unnecessary. That's why I have a local variable. Okay. Now we need to iterate through it again, and we're going to use what's called a running sum. Now, running sum is kind of fun. It's a bit like a lottery system. Let's say we were to have person A, B, and C. A put in 2 tickets for a lottery, B put in 3 tickets, and C put in 4 tickets. So like any lottery system, you can get more tickets or less tickets. More tickets will give you a greater chance of winning, And we'll see that in this case, this entire ticket pool would be equal to 2 plus 3 plus 4, which is equal to 9. And so we could view these in the context of our project as tile weights, and these are the tiles themselves, and this is the total weight. Now, from this, we're going to want to pick a random number in this range. So let's say number 6 got picked. And this is the random. Now we can iterate back through all of these people, and then whenever we add up and reach the random, that is going to be who wins. So we're going to start with A. We're going to add in 2. So we need to start at 0. So we'll start at 0, and then we're going to add in person A's number of, what was the analogy I was just using? Lottery tickets, yes. they're tickets. So that will then be equal to 2, which is still less than 6. Okay, so then we're going to add in 3, which is equal to 5. So that's still less than 6. So we still haven't hit that random. So we know that neither A or B won. And then we're going to add in these last 4 tickets. And we'll see that that equals 9, which is greater than 6. And therefore, C contains the winner. And this is just a way to utilize this is utilizing the weighted selection. So each individual will have an impact of varying degrees. You could change this more by increasing the weight of A, decreasing the weight of B, and keeping the weight of C to be the same. And then you would have a total weight of 13, which then if you were to pick a number, the random number being 2, we'll start at 0. We'll add in 7, as that's that number of tickets. And already we see that that is greater than that randomly selected number, and therefore A will be the winner in this case. So that's a bit of what a running sum is. It uses the idea of like a lottery system, and that's what we've implemented in here. So we're going to iterate back through the tile options. We need to promote the array element just to a local variable called tile option, and we need to find that within the map again and add it to the running sum, a newly created local variable, and promote that to a local, or set that. And then we want to check it against the random weight. We want to see if the random weight is less than the running sum. If that's true, we're going to break, and then we're going to output that tile option. If it's false, this for each loop will keep iterating until it finds a running sum that is greater than the random weight. Now, the last thing we need to do is off of this false. If the length of our array is equal to 1, then we don't need to do all of this math. There's only one option, so we can just get the tile options array, get it at index 0 as there's only one index, and that is 0. That is the first index, and set that as the tile option. So that will allow the return node to get the correct tile option, whether it goes through here or goes through here. And we'll see now, as long as this is all implemented still, enabling the forward tracking to loop back into here. We will see once we play that in my case, I have increased the amount of weight that the filled tiles have, and it is a lot taller. There have been more filled tiles selected. We could decrease this down, and this would put it back to kind of like a base where everything's equal. We could even pick something like, I don't know, we'll do left dot. We'll crank that up to 1,000. And we see we have a lot more height just because the left dot enables things to go up. So that's how we can create a weighted selection system and start to impact our collapse a little bit more. And this, in combination with the next video being seeds, will allow us to actually have set seeds that we can directly impact and see how things will change seed by seed. I hope that made sense. This is a bit of an interesting concept using the running sum. Anyways, feel free to ask questions as always. Goodbye.